Happy day and welcome everyone. So what today's lesson is going to be on is how do we figure out these solve it concept builders where we have to fill in all of this information going around this FBD or free body diagram. And so what I'm going to do is I'm going to kind of guide us right through there. We've got some notes that we're going to end up discussing here. And then we're going to basically take a look at a few problems together. So starting at question 5, and then we'll do some of the problems on the back together, okay? So one of the main ideas here is Newton's second law. Newton's second law states that force equals mass times acceleration, F equals ma. And you're going to really want to make sure that you remember that. And I always say, I want food, ma. And so that's an easy way to remember it. The F is up here, and then MA is down here if you're using an algebra triangle. Knowing the units is going to be really important. So remembering that force is in newtons, mass is in kilograms, acceleration is in meters per second, or meters per second squared. Okay. So one of the things that I actually start with is talking about FG, which is not the same thing as F net. Okay. And so FG is actually your weight or the weight of something, okay? And weight is different from mass. We're going to talk about this later on, but weight is different from mass because weight can change. Mass doesn't change ever, anywhere. You can be on the moon. You can be on Mars. Your mass is always going to be the same. But weight is actually according to acceleration. So your weight can be different depending on where you are. For example, if you're on Mars, maybe the acceleration due to their gravity might be something like 3.2 meters per second squared instead of 9.8 like we have here. So it's going to be something really nice to remember. So there are two separate equations that I really want you to keep in mind. You can repeat them to yourself over and over again, but we've got Fg, the force of gravity, which is weight, is equal to mass times 9.8. Okay, so again, force of gravity equals mass times 9.8. This AG, or acceleration due to gravity, is always 9.8 on Earth. So as long as everything's on Earth, we know that. This F is F net. It's not F friction. It's not F applied force. It's not your normal force. This is your net force. So I want to make sure that we remember what net force means, okay? So the net force, if we take a look around a free body diagram, the net force is going to be the sum of all of the forces going around. Pretty easy. So if we take a look at this first one here on the left, we know that the 25s are going opposite of each other. One up and one down. We subtract, we get 0 in the up-down direction. But there is a force of 50 newtons to the right. And so because of that, we know that our net force here must be 50 newtons. So I'm going to say 50 newtons. It is to the right. They may not be asking us for the direction, but if they do ask us for the direction, we know that it's in the right direction. So this one right here is going to be a little bit different. So I have the 25 up, down, but I have the 50 to the right, but now I have 20 to the left. So that means that there's something pulling it back. Maybe it's friction, maybe it's an applied force to the right and friction to the left, or something like that. And remember, what you do is if they're going opposite of each other, you subtract. So we get an F net of 30 newtons, okay? While we're here, I want to show you something, because sometimes what ends up happening on these concept builders is sometimes they give you one of the forces. So let's say I know the applied force is 50 newtons and they give me the net, and I'm trying to figure out what this one is. So they might give you a box, an open box, and you're trying to figure out what that one is. So here's the way that we do it. If this arrow on the left is smaller than this arrow on the right, then what I'm going to do is I'm going to take my net, which is 30, this 30 down here, and I'm going to subtract the difference between 30 and 50 newtons. And so this is going to be 30 minus 50, or 50 minus 30. It's the absolute value of it anyway. And I get 20 newtons, which is what I said before. Okay, now I just want to check your answer, because 20 to 50, again, is 30 newtons, and that works. Okay, but watch this. So what I'm going to do now is I'm going to go back to my 20 newtons. And so let's go back and say that we had it the way it was before. And instead, let's say I'm trying to figure out the right number. So let's come out to, let's say that they tell me my frictional force is 20, and I'm trying to figure out what my applied force is. Okay, now it's the bigger arrow that I don't know. And so if it's the bigger arrow, instead of subtracting, I know that I'm going to need to add. to the 20. So this number here is actually going to be 30 newtons, which is my net, plus the 20 newtons, which is equal to 50 newtons. And again, you can check your answer. If you do it wrong, your net, this net amount is not going to match, okay? And so if you do it incorrectly, you'll know that you did it wrong because it doesn't match, okay? So I first wanted to make sure that you understood net force because that's something that we've already done. All right, so there's a quick video, and I'm going to just click over to it here in 1 second. Okay, so let's take a look at this video. He's going to tell us to basically predict whether the medicine ball or the basketball is going to fall to the ground first. And he's going to ask a few people. So I'm going to fast forward in just a second and just see what some of the people believe is going to happen. I'm assuming that you're probably thinking the same thing.
I want you to make a prediction. In my left hand, I have a standard size basketball, and in my right hand, a 5-kilogram medicine ball. If I drop them both at exactly the same time, which one will hit the ground first?
This is a trick one, isn't it? The heavy will go down first.
Well, yeah, it'll drop faster. They'll both hit the ground at the same time.
Give me a
I
prediction.
actually would have thought this one would go faster because it's heavier. Maybe it's that one. Maybe this one, yeah.
So you reckon this
I
will be
reckon that one will be faster.
So why does that make it go faster?
Because
Okay, so let's fast forward to check to see what actually happens when they do drop the 2. So hopefully you made your prediction here.
You get really high, can you? Okay, on the count of 3, ready? 3, 2, 1.
Oh, they both hit at the same time. Same time, same time, same time.
exactly the same time.
Okay, so let's fast forward now to get an explanation as to why.
Now, it's not actually weight that holds it back, but inertia. That's the tendency of matter to maintain its state of motion, so to remain at rest if stationary, or to continue with constant velocity when in motion.
What's the big idea?
The big idea is this one has more mass, so it's got more weight, which you can clearly feel, but it's also got more inertia, which means it's also more sluggish.
Right.
It tends to resist acceleration. So that greater force is required to accelerate it at the same rate as this ball.
Like a heavy car trying to accelerate.
Like a heavy car trying to accelerate, you need more force to get it going.
Weight pulls it down quicker.
Okay, so the question is, what is that big idea? So the big idea is that the force to inertia ratio is actually going to be the same. In other words, the heavier ball has more mass, which means it has more inertia. Remember, inertia and mass are directly related to each other. And that means that it's going to resist change more. So even though that one's heavier and it's coming down, you would think it's coming down faster, it's also going to resist the change. So as it turns out, the basketball and the medicine ball are going to end up on the floor at the same time. Okay. So let's take a look down here. So then we were looking very closely at this equation, Fg equals m times 9.8 or times Ag. And so we can see here that in order to calculate Fg, it's really easy. You take the mass, you multiply it by Ag, and you're going to get your units of Fg. Again, that's weights, okay? So you can figure out the weight of any object on Earth using that. So in this question here, there was a skydiver, and so it was asking what her acceleration was. So what we figured out was they told us that she weighs 68 kilograms, so we were able to put that in. And then, and if you know her mass, you can calculate her weight by doing 68 times 9.8. That's called Fg. So whenever you know the mass, you can always figure out Fg using this equation. So that's how we got the 666. They told us that the force of air resistance is 400 newtons, and we know that goes in the opposite direction. So we can figure out F net. Once we know F net, now we can use our triangle. And remember, the triangle is simply F equals MA. So if I want to know A, then I cover up A and I do F over M. And so you can see here that I did A equals F over M, and then we were able to figure out what that answer was. So now let's try out question 5. So this one's an easier question, and what I want you to do is I want you to pause and take 2 minutes and see how much of this you can actually get filled out on your own, okay? So we have a rightward force to a 6 kilogram object. As soon as I see a number, I'm going to plug it in. I know that kilograms is going to be my mass. Then it says it moves it across a rough surface and it's at constant velocity. That's going to be important. It encounters 15 newtons of frictional force. So that's my FF is 15 newtons. Perfect. Neglect air resistance and fill in the blanks. Now I want you to think about what you know about constant velocity. Well, if the velocity is constant, don't forget everything here should be equal, or going around, right, on my arrow. So my up and down should be equal, my right, left should be equal, which means my net force should be, I hope you said it, 0 newtons. And if it's a net force of 0 and it's constant velocity, is it accelerating? Remember, accelerating means it's speeding up or slowing down. It shouldn't be accelerating either. So those are both zeros. So now let's figure out the other lines that we're missing. My right and my left arrows should be the same, okay? So if these are the same, because it's constant velocity, and then these two should be the same. So since it's constant velocity, if my left is 15, my right should be 15. Now, gravity. This is Fg. I know it says GRAV, but this is Fg. And so we know that we can do a calculation. Fg is equal to m times Ag, which is 9.8 meters per second squared. Memorize it. Remember it. Okay, it's going to help you. So what's my mass? Well, my mass is 6 kilograms. So all I need to do is multiply 6 times 9.8. So let's get the calculator out. And 6 times 9.8 is equal to 58.8. Okay, so that is my gravity. And remember, force is in newtons, so I'm going to put an N there. Well, if that's 58.8, my up and down arrows should be equal to each other. That means this should also be 58.8 newtons. So we're done. We filled in everything and we're all set. Okay. All right, let's take a look at the next page now. So what I want you to do is on the top of the page, I want you to write some things down. And you may already have some of the equations written. First thing I want you to write is Fg. And we know that it's mass times 9.8. We call this Ag. Okay, so it's m times a. It is m times a, but if you know your mass, you can always figure out Fg or the other way around. The other thing I want you to write, and by the way, that's weight. The other thing I want you to write is F equals ma, and I want you to point an arrow to the F, and this is your net force. We already have our triangle here. That's very helpful. The other thing I want you to do is know that force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. So let's make sure that we remember those things. That's going to really help us when it comes time to do the concept builder. I want you to pause here, try out question 6, see how you do alone, and then come back and let's see if we can do it together. Okay? So I don't really have a lot of words here, so hopefully you got as many of the blanks filled in as possible. It just tells me that it's accelerating to the right, but I can see that. That's fine. So if it's accelerating to the right, if I know my down arrow, then my up arrow should actually be the same. So if that's 80 newtons, this should also be 80 newtons. Okay, thinking back about what we said about net force. If I know all of the values going around my FBD, I should be able to calculate my F net. So 80 and 80 is 0, but 50 minus 10, so to get my F net, I'm going to do 50 minus 10, which is equal to 40 newtons. So that's going to be my net force is 40 newtons. Next, I don't know my mass, but if I know Fg, just like I said before, I can always figure out my mass simply by using this equation. Now you can either do the algebra. I know that Fg is equal to 80 newtons, and so if I'm looking for m, then all I'm going to do is divide both sides by 9.8. The other thing that you can do is you can use your triangle. So the way the triangle is going to work is, if I know, we can even just rewrite the triangle so that we get used to it. So if I know that I'm looking for, my mass, then it's F over A. So all I'm going to do is, which is exactly what I did, this is my force. This is my Fg, and this must be my Ag right there. Okay, so it's really just F over A, so keep that in mind. So I'm going to do 80 divided by 9.8, and if I divide that, I get 8.16. So it doesn't matter which way you do it, you're going to get 8.16. And remember, mass is in kilograms. Okay, last thing. I need the A, the acceleration. They didn't tell me anything about the acceleration, but once you know any two from your triangle here, so it's a triangle, so if you know two of the variables, you can always figure out the third. So to figure out my A, again, what I'm going to do is I'm going to use my triangle, and I know that A is equal to F over M. But it has to be this F, and it has to be this mass. Well, the mass is always the same, but the force could be different. So let's do the calculation. A is equal to F over M. My F is 40 newtons. My M is 8.16 kilograms. And 40 divided by 8.16 is 4.9 or 4.90. So that's going to be my acceleration. And remember, that's meters per second or meters per second squared. Okay, so hopefully you did great on that one. Let's try the next one. Go ahead and pause. Take about 4 minutes. See how long it takes you. Hopefully it doesn't take you that long. These should be done in under 2 minutes if you know what you're doing. All right? Okay, so I'm going to get right to it. So I have a frictional force of 44.4 newtons. So I'm going to plug that in right there. Then it says I have a 6.1 kilograms. So I have to use all my numbers. That's my mass, 6.1 kilograms. Then it's accelerating left, and that's all they're telling me. Right away, I know that if I know my mass, I can figure out my FG. So FG is equal to M times 9.8 meters per second squared. So my M is 6.1 kilograms. So if I multiply 6.1 times 9.8, that gives me 59.78 newtons. Remember, that's a force. That's my FG. This is FG. So 59.78. Now, if I know that, then I must know my normal force because these should be equal to each other. It's accelerating, it's moving to the right. So if it's moving or accelerating left but moving right, then I know that my up and down should be exactly the same. So that's 59.78 newtons. Okay, now I need the net force. Well, these two cancel out. All I'm left with is the 44 on the left. So that must be, this here is my net force because that's the only force I have is my frictional force pulling back to the left. There's no applied force to the right, so that's the only force I have. Okay, and then don't forget, once you know two of these, you can use your triangle. F equals MA, and I don't know A, so if I need A, I'm going to do F divided by M. So A is equal to F over M, and it has to be this F and this mass. Obviously, again, the mass is the same. So 44.4 divided by my mass, which is 6.1 kilograms. Let's put it into our calculator. 44.4 divided by 6.1. And I get 7.28. And this is acceleration. So now my units are meters per second or meters per second squared. All right. Okay, last one. And hopefully you got those all right on your own. Maybe there was only a couple of things to get. This is the hardest one. Okay. So this one, again, set your timer for 4 minutes. Go ahead and try it out. And then let's see how you ended up doing. Okay. So we've got, I need to use all three of these numbers. Okay. So the first one says it's a rightward force of 1,000 newtons that is applied. Okay. So I know that's my applied force, 1,000 newtons. Then it says it's a 53 kilogram object. Okay, great. That's my mass. Let's put that in there. Then it says it's accelerating to the right at 17 meters per second per second. That must be my acceleration. 17 meters per second per second. Okay, perfect. So a couple of things. One is, remember when I told you, if you know the mass, you can always figure out FG. Let's do that and get that out of the way. The other thing that I told you is, if you have 2 out of the 3 of these, then you can always figure out the one that's missing. So if I know M and I know A, I can actually calculate F. So we could do 2 things right now. It doesn't matter which order we do it in. Let's do the FG since I always like starting there. So I'm going to do FG is equal to M times 9.8 meters per second squared. And my M is 53 kilograms. Okay, so let's multiply 53 times 9.8. and I'm getting 519.4 newtons. Remember, that's my FG, 519.4 newtons. If this object is moving right, it's accelerating right and moving right, my up and down arrow should be the same. So if that's 519.4, this should be 519.4 newtons. Okay, so now we don't know friction. And the reason why is these are not the same. So I don't know what this one is, and that's definitely not the same as the other one. So let's figure out the F net first and then see if we can figure out friction. So we said we can use our triangle because we already know 2 out of the 3. We know the acceleration, we know the mass, we can figure out F. And in this case, F is equal to M times A, not times 9.8. That would give you FG, not F net. Okay. So I'm going to plug in my mass is 53 kilograms. My acceleration is 17 meters per second squared. So 53 times 17, and I get 901. And again, it's a force, so it must be in newtons, 901 newtons. Okay, going back to what we talked about over here, if the arrow is smaller for the one that you're looking for, you're going to subtract your F net from the other one. If your arrow is longer than the other one, you're going to add. Okay, so let's take a look and see, is this arrow shorter than this or longer? Well, it definitely looks to me like it's shorter than my applied. So if it's shorter, I'm going to need to subtract. And what am I subtracting? I'm going to subtract, to get this, I'm going to subtract my net, which is 901, from my applied, or the other way around. So if you get a negative number, just make it positive. So it's 1,000 minus 901, which is equal to 99, and that's newtons. And by the way, if you did it wrong, you would know, because if I added the 2 and I got 1901, that doesn't work out the same way because this arrow's shorter. That doesn't make any sense. If it's shorter, it should be less, right? Okay, and hopefully you ended up getting those all right, or maybe this was a review for you. Happy day, and thank you for being here.